Hello everyone, welcome back to my channel. I'm so glad to see you all here. So today is going to be a very quick video talking about what is set.seed in R. You might have noticed me using set.seed in a couple of my scripts, or maybe you might have noticed this set.seed function being used in some of the other R scripts, and a lot of you did reach out to me to ask me what is the purpose of the set.seed. So I decided just to create like a short video to explain the use cases or the purpose of using a set.seed in R. So essentially the set.seed function in R is used to create reproducible results when writing code that involves creating variables that take on random values. So by using the set.seed function, you are guaranteeing that the same random values are produced each time you run the code. So whenever you use certain functions which takes certain random values or generate certain random values, each time you execute your code, you will obtain a different results. So that means that the code is not reproducible because you don't know what the seed that R uses to generate that random sequence. It is possible that you don't want your code to be reproducible, but there are several cases where reproducibility is desired, and that is what the set.seed function in R is used for. So I will quickly demonstrate two examples where I will be running certain functions without set.seed and with set.seed, and hopefully the output or the results will make it more clear as to the purpose of using set.seed in R scripts. So in the first example, let us generate 10 random numbers. So in order to do that, I will run a function called runif. This essentially samples or generates 10 random numbers from a uniform distribution. And here I will be providing the number of observations that I need. So after running this command, you can see that there are several numbers that are generated. There are 10 random numbers that are generated. Now let us run this function again. And you'll see that this time it generated different set of 10 numbers. Now let us see what happens after we set seed. So we set seed, and I'm going to run the command again. And after running set seed, it generated some specific numbers. And these numbers are again different from the first two times that we ran. Now let us run set seed again and rerun the runif command. And now you will see that this time when we ran the runif command, it generated the same set of values it generated the previous time when we ran with the set seed. So essentially set.seed is ensuring that the same set of random numbers are generated every time you run this command. I chose 123 as the initiate seed value. You can choose whatever number you like. Now in the next example, I want to use the set.seed function in order to ensure the reproducibility of the UMAPs that we create when we are running the single cell data. The UMAP algorithm makes use of randomness both to speed up approximation and in order to solve optimization problems. This means that different runs of UMAPs can produce different results, although the variations are very minute, but still the results would vary a little bit in every run. So in order to ensure that the results can be reproduced exactly, we can use set.seed to ensure that every time we run the UMAP, it generates the same exact result. So for the second example, let us load the libraries first. So the data that I will be using today to quickly show you how we can ensure the reproducibility of UMAP, I will be using human peripheral blood mononuclear cells from a healthy female donor obtained by 10x Genomics. And this is the data set that we used to annotate single cell in the previous video using single R. I had run all the steps until the clustering steps and saved the object into a .r data file, so I can quickly load that object and perform the UMAP steps with and without setting the seeds to basically show you how different runs of UMAPs can generate different results, and by setting seed we can ensure that every time UMAP is run we get the same result. So let us load this data first. So as I said previously, I have run all the steps until the clustering step for this dataset, and now I have to run a UMAP. So in order to run the UMAP, we use the run UMAP function from the Serat package, And this function essentially has a parameter called seed use, which is set to a particular or a default value of a certain seed value. But since I want to demonstrate to you how the different runs of UMAP generate different results without setting seed, I'm going to set this to null. And let us save this into an object called before set seed run 1. Now in order to visualize the UMAP, we use a function called dimplot, and we provide with the object name, which is before set seed run 1. And for reduction, we use UMAP, and let us visualize this. So here we obtain 25 clusters. So this is the UMAP that we get when we run the UMAP without setting seed. So this is the first run. Let us rerun this again, so we will be able to see the difference. I'm just going to save this into a variable. And now let us run it again. And I'm just going to change, I'm just repeating the same process. I'm going to run the UMAP again. And now I'm going to save it into another object called run2. This is just to visualize how different runs of UMAP generates slightly different results. So I'm going to run the UMAP again. And now that UMAP has finished running, let us visualize this plot. So what I'm going to do is I'm going to save the output of the dim plot. So basically I'm going to save the plot into another variable and visualize both these plots side by side, so we will be able to see the difference. So I'm going to use grid arrange function to arrange the plots side by side. So now visualizing both the plots side by side. So this is the UMAP that is generated from the first run, and this is the UMAP that is generated from the second run. For both the runs, essentially UMAP identifies the same number of clusters, but you will be able to observe minor differences in the way the cell clusters. And every time you will run a UMAP, there will be minor differences and you will essentially get a slightly different plot. So in order to ensure that you get the same output or the same plot every time you run a UMAP, it is essential to set a set seed function, essential to set a seed in order to ensure that every time you run a UMAP, you get the same plot. So now let us run UMAP on the same object, but now in this case we will set seed. So in the parameter for seed use, we will be providing a certain seed value. And we will save the output of this into another object called after set seed run 1. So now that UMAP has finished running, let us visualize the UMAP using a dimplot function. We provide the name of the object and the reduction to use, that is UMAP. And I'm not going to visualize this now. I'm just going to save this into another variable called b1. I will be running this again because I want to ensure that multiple runs of UMAP will essentially generate the same plot. So I'm going to run it again. I'm just changing the output object name. Again, you will notice that I'm using the same seed, and the reason is because I want the same output. So I'm just going to change the output object's name from run 1 after set seed run 1 to run 2. I will be running the dimplot function on the second run object and will be saving it to another variable called p2. And now let us visualize both these runs side by side. Now after setting seed, you will be able to see that both these runs generated identical UMAP plots. So every time subsequently when you run a UMAP and you set the same seed, every time you run, you will essentially be getting the exact same plot. So basically setting a seed will ensure that your results are reproducible in terms of you will be getting the exact same output every time you run certain commands. So for UMAP, you do not necessarily have to set a seed, because by default it sets a seed value. So every time you're running the run UMAP command from the setup package, you might not have to specifically or explicitly specify a seed value. It automatically or by default set a seed value for you. So that was a quick video on set.seed function in R. I hope this video was helpful. As always, I will be uploading my script to my GitHub repository and linking the GitHub repository in the description section below. So if you like this video, please make sure you hit the subscribe button, like the video, share it, and leave your comments under the comment section. Until next time, see you.